Hey everyone, welcome to the Flutter development series from Roman Just Codes, where I'll be developing beautiful user interfaces with Flutter, and in this video, I'll be storing data into Firebase Cloud Firestore while continuing making progress on this app. In this series, I've been building the UI for a fictional grocery and produce app. And for this episode, I'll be covering the storing of shopping cart items associated with the logged in user back to Cloud Firestore, as well as adding the ability to add and remove shopping cart items while always being in sync with Firebase. This is what we'll be accomplishing in this video. Recall that in the previous video, we used Cloud Firestore as the backend service and data repository for this app, and we pulled category data initially. Now we'll be tapping into the existing Firebase Authentication framework to associate a logged-in user with its shopping cart data, while allowing anonymous users to only view the product catalog but not add anything to the shopping cart. When a user navigates to an existing subcategory, they will be prompted to log in order to add it to their cart. They log in with their Google account using Firebase Authentication. Then they can view the items in their cart, as well as add additional items to it. They can add any number of items, as well as increment their amount, and notice how that gets persisted into Firebase in real time, with very low latency when performing updates over the wire. Users can remove individual items, which also get removed from the cloud simultaneously, as well as clearing their whole cart, all synced with the cloud. They can recreate their shopping cart all over again, and the data both in the cloud and on the client side are synchronized. The speed at which the updates occur is impressive, highly responsive, only accomplishable by a serverless backend like Firebase. Anonymous users, on the other hand, cannot view any cart items. They are prompted to log in, which they can do right from this point as well, for convenience. The app recreates the state of their cart exactly how they left it last time, providing a seamless, uninterrupted experience. The app also supports multi-account experience. Log out and log back in with a different Google account, and your shopping cart data is recreated as stored by that user. Shopping data is stored associated with the logged-in user, thus not conflicting with any other user data stored in Firestore. Back to the previous user and their data is intact. Let's proceed. Let's recap the workflow before working on it. Our app authenticates the user with a Google account using Firebase Authentication, which assigns our user a unique user ID. We'll use this ID to uniquely identify this user among the other users and store their shopping cart data in Firebase Cloud Firestore under a collection called Shoppers. We'll maintain their data separately and keep it in sync, regardless of how many users log in and authenticate against our system. Unauthenticated users won't have any access to this data. Okay, now let's work on it. Let's start with a login model. Since this model will hold on to the unique ID generated after Firebase Authentication, let's create the corresponding property for it. Let's call it UID type string. Add a constructor parameter for it. Let's now go to the LoginService, which encapsulates the authentication functionality. Right after we obtain the user credentials, after logging in with Firebase Authentication, extract the UID from the user property available in the user credentials model. Make sure this service is refactored to extend change notifier now, since we'll notify other widgets about the user being logged in. Of course, add the corresponding notify listeners call to this method. At the bottom of this service, I'm going to create a convenient method called isUserLoggedIn, which we'll use to check whether the user model is null or not, meaning the user is logged in or not. I think this is it for the login service implementation. Let's go to the main.dart file and change the provider widget wrapping this service, changing it from a plain provider to a change notifier provider. With that out of the way, let's focus on the CRUD operations we need to perform against our data in Firestore. First things first, let's create a method called load card items from Firestore. which takes a build context in order to tap into other services for relevant data. We'll clear the items collection up front, just in case of any previous user having loaded their data. Let's get a reference to the LoginService to extract the currently logged in user. We need a reference to the category service to get all categories already retrieved from Firebase and match them against the items in our cart. I also need a reference to the category selection service, because what if I have a currently selected subcategory, and if I log in from there, I want to keep the user in context, so I have to update the existing selected subcategory. Use the convenient method we just created in the LoginService called isUserLoggedIn. And if so, it is the only way we'll fetch data from Firestore regarding their shopping cart data. Grab an instance of Firebase Firestore, specifying the collection called shoppers. Next, grab the document associated with the authenticated user ID, then do a get. Hook up to the return future using the then option and grabbing a document snapshot out of it. Out of the retrieved document snapshot, you extract its data, wrapped inside a specific field called cart items. Use the field path option to get it. A document snapshot is kind of like an envelope enclosing the data read from a document in Firebase. You can use the get data option to get the whole thing, or the get passing just the field you're interested in. Moving on, we loop through all existing categories and their subcategories. And match the keys stored in Firebase with the unique subcategory image name. In Firebase Firestore, our cart items map object has keys and values. The keys correspond to the unique image names, and their values are the amount associated with them. If matched, extract the amount value. Assign the value to the corresponding subcategory to continue using the data stored in memory. Then, add a newly instantiated cart item which wraps the corresponding subcategory exactly how we're adding them locally in memory, which later we'll add to Firebase. You'll see. Check just in case whether the currently selected category matches on any of the ones added to the cart. For example, you're on the details page and you're currently looking at the selected subcategory, you definitely want to update its values, especially the amount. Look it up by matched subcategory name. After this, notify listeners as usual to trigger a widget rebuild on whoever is listening. Let's move on to the adding of items. Notice we're currently adding them to memory, to the collection items. Let's make sure the item gets added locally and then make sure we add it to Firebase as well. Import the context here as well, since we'll tap into other services for relevant data. Fetch the LoginService to tap into the logged in user member variable. We need its unique user ID to create a unique document and associate its data to it. Create a map object with a string as a key and an int as a value. We'll use the subcategory image name as the key and the amount of items per subcategory as the value under a cart items map object associated to a unique document using the logged in user's ID. Loop through all existing cart items and extract the required data to feed this map object with keys and values. Now, get an instance of the Firebase Firestore instance, query the collection called shoppers, query the document associated with the logged in user's ID. If it doesn't exist, Firebase will create it automatically for us. If not, it will find it and then use it. Now use the method called set. Set overwrites the existing contents of the document in question, which is what we want. We want to keep the client data and cloud data in sync, so we'll use the client data as the source of truth when it comes to saving. Inside the set, add an object with key cart items, and as its value, our newly created map with all keys and values. Hook up to the then method from the future returned, which implies a successful add operation. Here is when then you'll notify any listeners that the cart item has been added successfully and trigger a rebuild on widgets to update accordingly. Since this add method is only used in the details page and we added the context as a parameter, let's update it here as well, feeding the widgets context to the add method. That's all we need to do here at the moment. Let's reload and check our progress. First, log in as a user with a Google account. When you try to add items to the cart now, it overrides what was there before, which is okay, since we'll be fetching the existing data in there prior to overriding it in a little bit. You see the items being added to the cart as well, so we are synced. Add other items to continue testing. Good. We are all set with the add functionality. Let's do the remove, which will have much of the same boilerplate code. We fetch the login service to get the logged in user ID to get the associated document under the shopper's collection. And of course, for that you need the context here as well. Out of the item to be removed, extract the associated subcategory. Get the Firebase Firestore instance, grab the collection, find the document with the unique user ID, and remove that exact entry that matches on image name. Using the update method and the field value.delete option. This deletes the whole key value pair out of the map, which is what we want. Check also how I'm using this dot notation to fetch nested values out of a Firestore map. The key is card items, and I query a subkey that matches on image name. I don't have to extract the whole document. Loop through the keys, find the corresponding one, then delete it. Pretty neat and convenient. Same as before, hook up to the .then, which implies a successful removal, and then and only then, you update the subcategory instance in memory, reset its value to 0, which then it is safe to remove the card item from its collection, then notify listeners to update accordingly. The remove method is wired to these remove buttons next to each card item. So let's go to the shopping list page and update their event accordingly. Just pass the widgets context and you should be good to go. Let's take it for a spin. Log in again. Add an item to the shopping cart. Remove it. See the whole key value pair disappear instantly from Cloud Firestore. Rinse and repeat. If you attempt to do a remove all operation, they only get removed from memory and not from Cloud Firestore. We'll wrap that implementation in a moment. I'll remove them manually from the Firebase console to start from scratch. Same drill, pass the context to the remove all method. This one will be pretty straightforward. We'll just blow up the whole map out of the document associated with a logged in user. We'll use the same collection, same document with the update option, but with the field value option of delete, but at the root level as opposed to a nested property. Then, on a successful removal, it is then when we clear all items and notify all listeners as usual. We also loop through all instances of each subcategory wrapped inside a card item and reset them. Update this method accordingly where it's been used in the shopping list page widget by passing the widget's context required. Check it out. Add a few items first. Test the existing single removal. Good. Do a remove all. Also good. Notice how the whole map got obliterated from Cloud Firestore almost instantaneously. Let's continue. So add a few items to the cart. All good so far. Here are the items added to it. Now, try to log in anonymously into the app. You see, the previous shopping cart items remain there. We need to do a better job at cleaning those from memory for either the next user coming in or another anonymous user. Doing a full reload on the app and clearing the previous state and anything in memory, sure, that gets cleared, but not all the time users are closing and opening the app after clearing their cart. We want to be able to load them both when we switch accounts or when I come in initially. This is where we will use the method we implemented earlier called load card items from Firebase. Go to the main page.dart and fetch an instance of the CartService. Right after, Call the load card items from Firebase method, which will fetch the card items for us and load them onto the shopping list page. Remember what it does. We check whether we're logged in, match all existing subcategories against the ones we have added in our cart in Cloud Firestore, and replenishes the card items. Lastly, it notifies all listeners. Let's do a full reload, resetting its state. First, check in as an anonymous user. Nothing in the cart, as expected. Now log in as a user via Gmail. And boom, there you go. Loading your cart's items up front and showing them to you just as you left them last time. Resetting, logging back in, and it keeps loading them accordingly. Once again as an anonymous user, nothing on the cart. Back again as a regular user. There are my items. Quick and accurate, and fully synced. Firebase Cloud Firestore stands out due to its speed, responsiveness, and of course, how well it plays with UI frameworks such as Flutter by providing a reliable and solid backend and data store capabilities. Let's go over something again. If you are an anonymous user, we're still letting you view the items and attempt to add stuff to the cart, which we shouldn't. We'll be working on that. But first, let me wrap up this small feature here of hiding the remove all option when you have no items on your cart. Check it out. Remove all items, whether individually or all at once. We still see this button up here. Let's add some logic to hide it if there are no cart items at the moment. Let's go to the shopping list page widget and locate this button. Wrap it inside a consumer widget that listens to the CartService. Query the length of items added to the cart and only return this button if the length is greater than 0. Otherwise, return an empty container. Reload and test. Of course, an anonymous user doesn't show cart items. But let's log in to a user which has items, a different user. Notice you see the option when there are cart items. Log out and log back in as anonymous. No items and no option, as expected. Now we can work on this feature, that even though you're anonymous, you can still see the logged in user options. Let's prevent this. Let's start with the shopping cart items badge widget up here. We need to only show it when the user is authenticated and logged in. Wrap it inside a consumer widget that listens to the login service. Check whether the user is logged in via our convenient method created. And return that widget, otherwise return an empty container. Let's give it a shot. Go in as an anonymous user. Nothing should show. Now let's handle the bottom portion of the details page widget. All the children in this column are what make up the bottom region of this widget. We'll do the same and wrap them all up inside a consumer widget that also listens to the login service. Let's do the same and check whether the current user is logged in by running the logic and assigning the resulting widget to this local user actions widget variable. If the user is logged in, return the widget tree wrapped inside a column widget. Otherwise, build the alternate widget structure for when a user is not logged in. Let's make sure things are properly in place. Now, we'll build the structure inside this container widget. Add a column with its children's center aligned. I'll add my custom icon font widget with color gray, 50% opaque, with a decent size. Some vertical space in between using a sized box. A text widget with some text prompting the user to log in. Additional vertical space, and a custom button widget I created earlier. Let's add some top padding to give it some breathing room. This button should handle the capability of logging the user in right from here by tapping into the login services sign in with Google method. Handle its success, and if so, right from this spot as well, load the card information from Firebase via the CartService. So as opposed to being done on the main page widget, we do it here and it propagates throughout. Reload and try. Clicking the button triggers the authentication workflow. And right in place, it should bring you right where you left off. Let's do it once again. Go back in as an anonymous user, trigger the authentication workflow. Add this item to the cart, you see it in Cloud Firestore. Now try to increase its amount. Nothing happens in Cloud Firestore. Add another one, nothing either. Let's add the capability of modifying an existing item in Firestore now that we can add and remove. Go to the category selection service and work on both increment and decrement capabilities. In the increment subcategory amount method, pass the build context to it. Same as before, tap into the login service for the logged in user information. Tap into the CartService for shopping cart information. Since you're in the details page already, thanks to selecting a subcategory, check if its subcategory is already in the cart, so we can update it in place. If so, same drill with the Firebase Firestore instance. Query the shopper's collection against the document associated with a logged in user. And use the update option to just increment the value of the specified key from the selected subcategory's image name that we are using as unique key. Then use this convenient utility from Firebase, fieldValue.increment, passing the value to increment your property by. I'm incrementing it in values of 1, very convenient. Upon successful update, then you can update the value locally and notify listeners. Else, if the item is not on the cart, let them increment it, and only when they're ready to add, they can add it to the cart. This method is using the unit price widget, so refactor it there and provide its dependency, which is the build context. Take the increment implementation for a spin. Let's go for one of the existing items in the cart. Check that as I increment locally now, the existing value in the cart increments its value in real time in Cloud Firestore for this user for the specified item. Decrement not working. We'll get there. But guess what? It's pretty much a copy-paste of the increment, with the exception that we are not incrementing by 1, but decrementing by 1. But since there's no decrement method, you say increment by -1, and it works just as well. Upon successful decrement, then update the value locally and notify listeners. Else, let the user decrement and store a preliminary cart item to Firestore. Only when they're ready to add, then they will. Add the missing dependency in the unit price widget by passing the context. Now we should be able to see these values change in real time as we increment and decrement the amount. Notice the value flashing in Firestore both on increment and decrement and on individual items on the cart. Pretty cool. Back in as an anonymous user, no items in the cart as expected, and no access to the controls as expected. Log in as a separate user, then they'll be able to see their cart items. Switching back between authenticated users and anonymous users, each one should see their individual cart items with no issues whatsoever. I've tried several times logging out, logging back in as different users, anonymous users, and the application is in every chance displaying the correct information for each individual user. And even if I decide to add more items, the app handles it gracefully and seamlessly in an uninterrupted fashion. And with that, I rest my case that Firebase Cloud Firestore and Flutter are a match made in heaven when it comes to a great stack for developing connected, serverless, cloud-native applications. You can follow these videos if you want to take this app further and implement the favorites and settings page widgets, which would pretty much follow the same approach as far as adding items to a collection inside a unique document per logged in user and storing the IDs of the selected items per user and it is both applicable for settings and favorites. I can continue adding features to this app, but I guess I'll never end if I do. In the next set of videos, we'll wrap up this app by starting to package it up for publishing to both iOS and Android app stores. I'll add the app icons and launch screens for both platforms, and I'll go through the publishing process for both Android version to the Google Play Store and the iOS version to the App Store. And that should wrap up this series. Stay tuned for those. See you on the next video. That's it for this video, so please stay tuned for more upcoming videos. Hit the subscribe button to stay updated, and please like this video if you found it useful. Thank you so much for watching.